Hey everybody! Today we're going to be talking about electricity. So, first thing that we're going to talk about is the positive and negative charges. So, the protons exceed electrons, so that is going to be your positive charge. Your negative charge is going to be your electrons exceeding your protons, and your electric charges can be transferred between objects but cannot be created or destroyed. We did talk about that in another video. So, yeah. Alright, and then the next thing is, like charges repel, unlike charges attract, which means if you put two positive magnets together, like so, they're going to repel each other if you move them side by side. You're going to feel what's the word I'm looking for?
Resistance?
Resistance between, thank you, Mother, between the two. So they're not going to go together. They will not repel. But you can put a positive and negative charge together, and so they will attract. And then the next thing that we're going to talk about is our electrical conductors and insulators. For conductors, they contain electrons that can move easily, such as metals are the best conductors. That's why when, like if it's cold outside or if it's really hot outside and you feel metal, it is going to get hot quicker than like plastic or anything like that. So yeah, and then our insulators do not move easily. Electrons do not move easily, and they contain such as rubber, glass, and plastics, which are insulators. And then charging objects. Electric charge can be transferred between objects by bringing them into
contact.
Thank you. And an example I gave was a hair in a balloon, because if you were to rub your hair with a balloon, or if you were to rub your shirt with a balloon, or if you notice when you rub it and you try to pull the balloon off, it will attract your hair because your electrons, as you move, will come together. Thanks for tuning in. Hey everybody, I am back with current and voltage. So, what is an electric current? It is the net movement of electric charge in a single direction. So, now that we have that, let's talk about our voltage difference. Everyone needs to know what that is. The definition for that is the force that causes charges to flow. And then our resistance is the tendency of a material to oppose the flow of electrons. And then for Ohm's law, defines the relationship between the electric current, voltage difference, and the resistance. So, now that we know that, what is Ohm's law? It is the current in a circuit is equal to the voltage divided by your resistance, or it's your current, which is measured in amperes, but some people call it amps, is equal to your voltage difference, which is measured in volts, and your resistance is measured in ohms. And the symbol looks somewhat like this. It's kind of at an angle. Now that we know that, let's do our practice problem. What is the current of a circuit if the voltage difference is 25 volts and the resistance is 5 ohms. So we've written down our equation. Now we're going to plug it in. So with that. So we do not know our current because it's asking us what is our current, so we put a question mark there. Our voltage difference is measured in volts, so we're going to look at our problem. No. So we have voltage difference, which is measured in volts. So we're going to put 25. I'm just going to put V. And then our resistance is measured in ohms, like we talked earlier. And in our problem, we have 5 ohms. So we're going to put 5 there. See? And so we're going to plug it in again. So we're going to write C equals 25 divided by 5. And when you plug that in your calculator or you do it on your paper, it is going to give you the answer of 5. Nope. Just kidding. Amps. And now that we have figured out our answer, we have now finished our current and voltage. So yeah.